term divided by the previous. So in your problem, it would be like 4 divided by 1. Okay, the next is 4, the previous is 1. And then you check and make sure, well, is 16 divided by 4? So if you treat 16 as the next and 4 as the previous, are these the same? And they are. Okay, so what your instructor is looking for is either r equals 4 or just 4 there in this problem. Okay, so pretty straightforward. Now they give you a definition in the classroom. Might be like an plus 1 over an. Sometimes I think the words are much more meaningful than a formula like this one. All right, so let's look at problem number 2. Again, I will send you the notes at the end. I definitely encourage you to take notes or write things down as we go. But I will be sending you all of these notes at the end of the lesson. So the ratio in this problem, you can see that they're going down, they're getting smaller, but you take the 64 over the 128. Now you're probably allowed to use a calculator. Do you have one handy, or can you tell me the value of this when you divide 64 by 128? Okay. And if you don't have one, I'm going to send one in the chat here. That's good to use. Cool. So
Eric's got the rings down there.
So
What?
1/2.
1/2, yeah, or 0.5. Either are fine. And you just want to make sure that the next one, 32 over 64, is the same, and it is. So your ratio is 1/2. Okay. Now for the next problem, number 3, you can see that it's the same thing. I mean, that there's it's a recipe. You're doing the same thing over and over again. And in this problem, your ratio would be -20 divided by 4, which is -5. So the ratio can be negative. Okay, it can be negative. It can be positive. It can be a fraction. It can be a negative fraction. It can be any of those things. So any questions on that before we move to the next problem?
No.
Okay. All right, so the next problem here, a couple of ways to do it. Let me snip it in here on your screen, a couple of ways to do it. First thing though is I want you to find or tell me the ratio in this sequence.
So do you need to write it out? So you feel your next minus r divided by the previous.
Yeah, so sometimes I'm going to ask you to jump in and it's unexpected, but I think that's a great part of this format. So just let me know when you've got a value for that.
So 8 divided by 2 is -4.
Yes. Okay. And one way you can look at it, I'm going to write the sequence out down below here just because I need a little more room for what I want to show you. Next is to go from 2 to -8. You're multiplying by -4. You're multiplying by that R value. And similarly, to go from -8 to 32, you're multiplying by -4. Okay. And that's what the instructor wants you to see here. They want you to see this pattern. It's like, okay, I multiply by -4, -4, and to get that number, you need the ratio. Okay. So to get the next number, you're going to do the same thing. You're going to multiply by -4. So if you've got a calculator handy, take that value of 32 and multiply it by -4.
So sorry to interrupt here, but the positive and negative, how does that come into play? I guess never mind.
Yeah, so it's taken, yeah, but just for more explanation, it is taken into account by this value of R, but this is what's considered an alternating sequence. I mean, it's very important, but it's not really all that important to Algebra 2 student right now. It's just they tends to alternate. So the next one is going to be negative, is the point. Okay. And you want to look for that pattern, like, okay, it was positive, then negative, positive. Oh, this one's going to be negative.
Gotcha. Okay.
Maris, do you have an answer for me on this one?
Yeah, -128.
Good. So now you're going to do the same thing. you're going to multiply again by -4 to give you the next one. The numbers do get large pretty quickly. This one will be positive.
Minus,
No, it wouldn't be, it'd be positive.
oh yeah. 512.
Yes. And
I'm
what
trying
kind
to
of
use it.
calculator are you using on your side? Like a TI-83, just a scientific calculator? What are you guys using?
I usually use like a TI-83, but I didn't bring it because
Okay.
I just have my phone.
All right. I have a virtual TI-83, so I can show you how to use that calculator in a future lesson if you would like. But to get the next number, you got to take this current value and multiply it again by -4. So go ahead and do that and give me the answer for that one, please.
Oops, he didn't clear for me. Oops. There.
Sorry.
Take your time. It's important to get the right answer, and we'll get on to the next question after this. So
Minus 2048.
perfect. Okay. So really not that difficult. I mean, once you know this ratio, it helps you to determine what to do next to get this pattern. All right. So let's look at number 5. Number 5 here. I'm going to snip that into the screen, and we're going to take a look at this question. So just like the previous problem, we want to calculate the value of R, that ratio between terms. So you're going to take that next one, which in this case is 27, and divide it by the previous one, which is 81. And this time it's a fraction. So if you're using your phone, it won't be as valuable as that scientific calculator, which has some ability to reduce fractions, but this is 1/3. Okay, value is 1/3. Now, what's maybe unclear here is that you're always multiplying by R. Okay, you're multiplying 81 by 1/3 to get to 27. Okay, and that's probably the best way to think about it. But alternatively, you could think of this as division by 3. And the only reason that works is because it's 1 divided by 3. If there was not a 1 on the top, you could not think about it this way. But you can think, okay, 81 divided by 3 is 27. To get to 9, you are similarly going to divide by 3. So my question to you is what should we do next to get the next number in the sequence?
Divide by 3.
Divide by 3. Okay. So either if you know the answer, tell me, or if you need to grab that calculator, that's fine. I want to know what 9 divided by 3 is.
3.
3. Perfect. Do it again. 3 divided by 3.
1.
1. And last one here. So this is where kind of this approach may not work as well. When you divide 1 by 3, it ends up being a fraction 1/3. And if that's something you're uncomfortable with, we can definitely get some more familiarity, the more lessons that we do together. All right, any questions on that? Because 6 kind of transitions to a different style of question. Anything that you'd like me to answer before we move on?
Doesn't make sense.
Yeah, it makes sense.
Great. Okay, so here is a new question. So really not much different than the previous ones because they give you a sequence, okay? And then it says to write an equation for the sequence. So probably in your notes somewhere, you got a formula for a sequence. So I'm going to give you the formula in words here because that'll mean more to you. This is the first term. This is the first term. So each of these numbers are terms. Okay, so the first term is 3. It's always whatever number comes first goes on the outside. The number or thing that goes in here inside the parentheses is the ratio. Now we've done ratios now for 5 problems. Can you tell me the ratio between these terms? Can you give me that value of R, please?
2.
2. Perfect. Okay, so let me write it out a little bit different, so you can see this, because this is really what matters here. To get the nth term of the sequence, and we'll talk about this in more detail if we need to. Let's say you want the first term of the sequence. Okay, what that means is you're going to put this 1 in for the exponent. So it's 3 times 2 to the 1 minus 1 power. Okay, and you would find that this equals 3. I'm not interested in doing the calculations today unless we need to for a future problem, but that is why you're learning this formula. You're learning this formula so that you don't have to write out the sequences each time. You can, for example, let's say I wanted the 10th term in the sequence. It would get tiresome to have to keep going while you could do it. It's faster to use a formula. And we might see that in some future problems, but that's why they have you write the formula. Okay, so let's, if there's no questions on that, I actually should write down the formula here for you. So the formula, we've talked about a couple today. The ratio R is AN over, or AN plus 1 over AN. You've been doing that a bunch. That just means the next over the previous. And then the formula is the initial term. We'll call it the notation right here. We'll call it A1 R to the n minus 1 power. So whenever you see me box in something like this, it's usually something that you're going to need on a test or a quiz as a formula. Definitely would be good to get those down. But I'll copy them throughout the lesson if we need. So whenever you're ready, we can move on to question 7. Just let me know. We can go on to that.
Does that all make sense?
Yeah.
Okay.
Yeah, I'm ready to.
Yeah, Amy, if it's always good for the student to, stop me if they're not sure, or if I'm being unclear. This time is completely for you guys, whatever you want us to work through, and be happy to go over anything again, but it's all kind of leading to something here.
You can't see you shake your head. You have to say yes or no. 'Cause you took the
Yeah.
video off.
I keep. Yeah.
Good. Okay. Thank you. All right. So this problem says the first term of a sequence is 7. Okay. That's important. The common ratio is -2. Okay. Now it doesn't ask for it, but kind of like implied right here is to write the formula. Okay. So the formula is A0, or I'm sorry, A1, the first term, which is what they just gave you, times the ratio, which they also just gave you, to the power of n minus 1. So encoded in this first sentence, you as the math student have to be able to recognize it's this formula, and they're giving me the 2 numbers that I need. So all you have to do now from here is substitute those numbers into the formula. Is that clear?
Yeah.
Okay, so the formula is, and maybe there's some question about what these, like this n is and this 1 is, because you're not used to seeing subscripts in formulas. Did your instructor in class tell you or talk to you about these, or have you seen those before?
Not really.
Yeah, so you are somewhat familiar with them, and I'll just draw the analogy to slope formula. y2 minus y1 over x2 minus x1. It's the same idea here. It's like when you have 2 y's, if you think back to slope formula, there's 2 ordered pairs. You have to differentiate between them. You have to say, well, which one's the first one, which one's the second? And so this formula, or these subscripts in this formula, it's kind of the same deal here. So try not to get overwhelmed by it. The more you do it, the more you're like, okay, I get it. But A1 is replaced by 7, and R is -2 in parentheses to the n minus 1 power. Okay.
Yeah.
So you do this, but you still have to do the part of the question where it says, well, what is the 5th term? The 5th term. So the 5th term means that n equals 5. So a lot of math is like decoding. It's like, what do they even mean by that? It's like, well, it means that n is 5. Okay, so you're finding the fifth term. You're putting 5 in for n. So a subscript 5 equals 7 minus 2 to the 5 minus 1 power. Again, all I've done here is substitute that value of 5 in for n.
Yeah.
So the next step here is to simplify or reduce. Now, if you had a scientific calculator, you could probably punch this in exactly the way it's written, and it would give you an answer. Since we don't, we have to remember order of operations. There's an implied parentheses up here in the exponent, which means you're going to do that first. So that's to the power of 4. Order of operations says that you do exponents before multiplication and division. Can you tell me, or if you're not sure, you can ask, do you know how to calculate -2 to the power of 4?
Yeah, I think you can have it right. I think it's
16.
say it louder.
Is it 16 or?
Yeah,
Yeah.
so it's -2. I'm just gonna write it out just in case you want to look at it later. -2 times itself 4 times, which is 16. So this is 7 times 16. It's very important that it's all the -2. It's not 2 and then negated. And then, if you got a calculator handy, you can calculate this. Looks like it's 70 plus 40. Looks like it's like 112. Okay. So that is the final answer. That's what the instructor is looking for. So the process here is like, they want the fifth term, but you as a student have to know, oh, I'm writing the formula. Now, if we go back a problem, this problem had you write the equation or write the formula. And math is very much like walking up a staircase. You have to do, if you do this in the previous problem, you're probably going to do it in the next problem. And these are things that we will start noticing if you're looking at these problems from like one transitions to the next. Okay, so we're up to problem 8 here. Let's keep going here. Yeah, kind of the same type of problem. So that's good. Let me read this, get this snipped in here. Okay, so I want you to read this problem, and I want you to tell me the value of A1 and the value of R, please.
A1 is 2 and R is 4.
Perfect. Okay, and you got to have that down. That's like, you can't even go any further if you don't have those right. Here's the formula. AN equals A1 R to the n minus 1 power. It's good to keep writing the formulas down every time you do the problem. It will bring familiarity. You'll recognize it when you see it. And then from here, you're just substituting those numbers into the formula. And my recommendation is to always use parentheses for that number R. Even if it's positive, put R in parentheses. Just reduces issues later on. All right, so if you got that down, can you tell me the value of n in this problem? Which term are they looking for, in other words?
The 9th term.
9th term, yeah. So that means that n is 9, and you're just putting that value in for n. Okay, so to simplify this, just like in the previous problem, you're going to work on the exponent first. So you're subtracting 1, it's 4 to the power of 8, which is really large. Exponents get
You press X, Y, and then 8. Yeah. I'm just showing how to do it on the scientific calculator.
cool. Yeah, because you're going to need that.
Yeah. And it just comes out this way.
So make sure you know how to get that number that I just wrote down, or if you want to do it all in one step, you can, and get 131,072.
Yeah.
Okay, so let's look at question 10 next. We'll skip 9. 9 is almost exactly like the ones we just did. So you can definitely pattern it from the previous problems. You just change the numbers and you'll see that you can get it right. So 10 here, it says list the next 3 terms of each sequence. Okay, so they're for some reason they're giving you, well, they're giving you the formula. I mean, that's what you really want. And since they're giving you the first term, that's what goes, you can think of this as the first term. So they're already giving you the first term, okay? And the first term corresponds to n equals 1. The second term corresponds to n equals 2. Okay, so which means you're going to put 2 into the formula for n. So a subscript 2 equals -4, 2 minus 1 power. Okay, and if you got a calculator, you can simplify that. -4 times 2 to the power of 1. So any number to 1 is always itself. That's another kind of thing that might be worth remembering. So this becomes -8. You also might notice now that the terms are going up by multiplication of 2 from earlier, and that 2 comes from inside the parentheses. So while you could use the formula, you can sit here and say, oh yeah, I'm just going to multiply by 2. And that gives you a value of -16.
Yes.
Okay, so I'm jumping, just do one more thing here. Stop recording.